Hello everyone, so welcome to YourPedia Education. So today we are going to discuss very important questions that are related to your CIL exam. So before, as you know that registration are open and I think they are already closed, and this is a very good opportunity if you are from electronics and electrical backgrounds, right? As you already know. So in today's session we are going to discuss, right? We are going to discuss basically uh, about the analog communication, right? Our live classes are going on. If you want to prepare for that one, you can join YourPedia, right? And we already covered lots of subjects, right? Like EDC is covered, right? Currently we are doing with EMFT, right? So basically if you are from electronics background, you can join YourPedia, right? Our online classes are going on. So this session is related to your communication system. In this session I will discuss analog communication questions that are very important, that are most expected questions, you can say, from this analog communication topic, right, for your CIL exam. So let's start this session, right? The first question. What is our first question here? He says indicates the false statement, the need of modulation can best be exemplified by the following, right? Which of the following statement is not true, you can say, about the modulation, right? So when you are seeing there are four statements, the first statement is what? The antenna length will be approximate lambda by 4. The second statement is an antenna is standard broadcast AM band is 16,000 feet, right? All sound is concentrated from 20 hertz to 20 kilohertz. And another thing, a message is composed of unpredictable variations in both amplitude and frequency. So these are the four options are given to you. You have to tell me which option is incorrect. Yes, try to solve it. That is from analog communication and I will discuss it in detail. Just try to solve it. So basically he give you four statements and he asked that which of the following statement is false. If I go with the first statement where he says that antenna length will be approximate lambda by 4. So whenever you go about the practical antennas, remember that thing. Whenever you go with practical antennas, all the practical antennas are lambda by 4 length. So the length of practical antennas are always lambda by 4. Remember that thing. It means this statement is correct. This is not false. In the next statement, he says that an antenna is standard broadcast AM has a length of 16,000 feet. So how it decide how much is the length? The first thing what we have to understand here, that basically standard AM, right? When we are broadcasting the standard AM stations, right? The AM station broadcasting at which frequency? AM band, right? AM band generally lies in which frequency band? So if you go for the frequency of AM band, that will be 535 kilohertz to 1705, 535 to 1705 kilohertz. So this is the frequency band in which we are transmitting the AM signal, right? 535 to 1705 kilohertz. So this is the frequency band in which we are transmitting the AM signal. So let us take, you are broadcasting at this frequency. I am taking that 1.5 kilohertz. Oh, sorry, not 1.5, 1500 kilohertz frequency. I'm taking that, I'm broadcasting this station, and let us check how much is the antenna height required to transmit this frequency. This is the frequency F which you are using, you are transmitting. So at this frequency, if I'm transmitting this frequency, what is the wavelength of the frequency? So if you are going for the wavelength, what is the formula for wavelength? So basically f into lambda is equals to c. Here, if we go for wavelength, that is c by f, and c is 3 into 10 raised to power 8 divided by, if you take 1500 kilo means 10 raised to power 3. So 10 raised to power 3 cancel, 10 raised to power 5, and this will also cancel out. So that is getting, how much we are getting here? uh, 2 is cancel out 3, so that will going to be 15, that is 5. So around 10 raised to power 3, 10 raised to power 3 is getting 1000 divided by 5, it's come out to be 200 meter. So that is not 16,000 feet. It means this statement is not correct. So if you are using AM broadcasting, the antenna height will not be 16,000 feet. It will be around 200 meters only. That is very big number. 16,000 feet is a very big number, right? So that is lambda. Lambda is the wavelength. Now if you are going for antenna height, that is lambda by 4, and lambda by 4 is 200 divided by 4. It's around antenna heights which is required to transmit this AM station, that is 50 meters. So generally you are seeing whenever we are transmitting the AM stations, we are having antenna height around 50 meters, 20 meters in practical cases. So this statement is not correct. This is false. Another thing, all the sound is concentrated from 20 hertz to 20 kilohertz. So whenever we talk about the communication system, as you know, our most of the sound signals are lying at a frequency of 20 hertz to 20 kilohertz, right? On the same side will be the same spectrum. So whenever you are transmitting a whenever you are transmitting a voice signal, remember the sound signal that will have a frequency range from 20 hertz to 20 kilohertz. So this statement is true. And the message is composed of unpredictable variations in both amplitude and frequency. So let's take an example, right? Let's take an example. I'm speaking something. So this is a voice signal. If I'm transmitting this voice signal, that is having variation in frequency as well as in amplitude. What I'm saying here, it is having a certain frequency. So this voice message signal is always have unpredictable amplitude as well as the frequency. So it means the message signal is composed of unpredictable variations in both amplitude and frequency. This statement is true. So in this one, which statement is false? B statement is false. So what will be the correct answer for this question? The answer for this question is B here, right? B here. So this is the detail about this one, right? If anyone have any doubt related to that then please ask on the chat, right? Check it. Yes, that is correct. Okay, let's move to the next question. This is the complete solution for this question. Here we discuss every detail about this. Now, next thing is amplitude modulation is a process of. What is amplitude modulation? Yes. What is amplitude modulation? So amplitude modulation is a process of. What is amplitude modulation and what is this process? Tell. Yes, anyone? The amplitude modulation is a process of. What is the amplitude modulation? So any modulation, he says B, superimpose of high frequency on low frequency. No, that is not correct. Your B is not correct. See, basically, whenever we are talking about the modulation, any type of modulation, either it is amplitude modulation, frequency modulation, we are doing one thing. We are having a massive signal. Let's take my voice signal that is having very low frequency up to 20 kilohertz. So basically we cannot transmit that 20 kilohertz directly into free space due to there is a problem that is called as antenna height. So antenna height is a big problem with the system. So if we want to transmit that signal into the free space, we have to convert that low frequency signal into high frequency signal. So that process to convert a low frequency signal into high frequency signal, that is generally known as what? Modulation. That generally known as modulation. So whenever someone asks you that what is modulation, so modulation is the process to convert a low frequency signal into a high frequency signal. So basically what we are getting here, we are superimposing a low frequency signal on a high frequency signal. That is known as what? That is known as your amplitude modulation. Generally the amplitude modulation, we are, see, basically what is happening, we are having two types of signal. One is massive signal. This massive signal is a low frequency signal. This is a massive signal which is a very low frequency signal, and to transmit this signal we will use another carrier signal. This is called carrier signal, that is AC cos 2 pi fct. This is your carrier signal. Fc is very high, remember that. This is the carrier signal. So this carrier signal CT has three things. Let us discuss that thing here. That is AC cos of 2 pi fct plus phi, right? So basically this carrier has three things. This is amplitude of this carrier, this is frequency of this carrier, and this is phase of this carrier. So basically we will divide our communication, analog communication, into three parts. Whenever you you take your message signal, you wrap that message signal inside this amplitude AC, right? We wrap up your message signal inside this AC by using AM, DSB, SSB, which you discussed, you already know. So we take our message signal empty, we wrap that message signal inside this AC, the amplitude of the carrier signal, and we transmit that carrier signal, right? So your message will convey in the amplitude of this carrier signal. So that is known as amplitude modulation. Another thing, whenever we take this message signal, we wrap that message signal in this carrier frequency, right? You take your message signal, you wrap up that message signal in the carrier frequency. That is known as frequency modulation. And when you wrap up your message signal inside your phase of your carrier signal, that will be known as phase modulation. So generally we are having three types of modulation: amplitude modulation, frequency modulation, and phase modulation. In amplitude modulation, we are wrap up our message signal in amplitude of carrier. In frequency modulation, we wrap up our message signal in the frequency of that carrier, and in the phase modulation, we are wrap up our message signal into the phase of that carrier signal. So answer for this question is A. Yes. The peak amplitude of the basic amplitude modulated wave is given by which? Right. Peak amplitude of your basic amplitude modulated wave is given by which? Priyanka says B. Yog says A. Okay. Anyone else? This is a very good question, right? Whenever he says that the peak amplitude of your basic amplitude modulated wave. So whenever we are talking about basic amplitude modulated wave, the equation of a basic amplitude modulated wave SAMT, that will be equals to Vc plus Vm sine of omega mt into cos of 2 pi omega ct. Oh, sorry, not omega, this time fc here. 2 pi fmt and 2 pi fct. So this is your basic equation of your am signal. So tell me, in this equation, what will be the peak amplitude of basic amplitude modulated wave? Now this is the equation for you. You have to tell me what will be the peak amplitude of this one. So basically, if you are seeing here, this is the carrier signal, right? This is the carrier signal, and this factor, this complete factor from here to here represents what? That will represents your amplitude, right? That will represents your amplitude. So if you are going for the amplitude, basically what you are saying, if I am having a sinusoidal signal, let us take 5 chi cos of 10 pi t, right? I write this. So what is the amplitude of this signal? Hanji, yes, tell me, what is the amplitude of this signal? This 5 cos of 10 pi t, if you are going for amplitude of this signal, that amplitude, the peak amplitude of this signal is 5 or not? Yes, good evening. Shomya, good evening. Yes, we are discussing about this one. So if you are having 5 cos of 10 pi t, then what is the value? What is the amplitude of this signal? The amplitude, peak amplitude. I am talking about peak amplitude of this signal. The peak amplitude of this signal is 5, right? Always you know that one. So basically, if I draw the graph of this cosine wave, that graph is look like what? If cosine wave, sorry, that will be look like this. The peak value is 5 and the below value is -5, as you know. So whenever you are having a cosine wave and you are going for the peak of that one, that peak will be what? The amplitude of that one. So now if you are going for this SAMT, this is the equation of your SAMT, then what will be the peak? What will be the peak amplitude of that one? That peak amplitude will be Vc plus Vm sine 2 pi fmt. That 2 pi fmt generally denoted by omega m. So the peak amplitude is Vm sine omega mt. Remember what he is asking. You have to be read the question carefully before giving the answer. Before giving the answer, what he is asking that peak amplitude. Remember that thing. It is not asking peak envelope. There are two terms. Envelope is also there, peak envelope. If you go for peak envelope, then sine of omega t should be 1 there. Then peak envelope is Vc plus Vm in that case, right? That's the two different thing. Always remember, when he says peak amplitude, so peak amplitude means he is talking about the amplitude of this carrier signal. In the am case, that will be Vc plus Vm sine of omega t. If he is talking about peak envelope, envelope means what? Envelope means what? When you draw this, the graph of this signal, that graph will be look like this one, what you are seeing here, like this. So this dotted will tell you about this dotted line is the what? It is your envelope. So this maximum value is peak envelope. If he is talking about this peak envelope, that is Vc plus Vm. So this question is different from that one. If someone asks you peak envelope, that peak envelope value is Vc plus Vm. If someone asks you peak amplitude, the peak amplitude means what? this factor Vc plus Vm sine of 2 pi fmt. Check it. Should I discuss anything again? Just let me know. Or understood? So the answer for this question is what? The answer is D, neither A nor B. D is the answer, correct answer for this question. Yes, your answer is correct. That answer is A, but that is peak envelope. When someone asks you that peak envelope, then the answer will be A. He is talking about the peak amplitude, right? Okay, let's move to the next. Yes. What is the modulation index of your AM signal? What is the modulation index of our AM signal? Okay, A. Shomya says A, Yog says A, Priyanka says A. Yes, the game says A. Okay, so basically, whenever I write that equation, that SAMT is how much? SAMT is getting Vc plus Vm sine of omega mt cos of or cos or sine. We generally take sine or cos, it will be depends on your choice. I'm taking here sine of omega ct, right? So basically in this equation, if I take this Vc out, then it will become Vm by Vc sine of omega mt and sine of omega ct. So basically this factor Vm by Vc is represents your modulation index M. So here the modulation index M is Vm by Vc, always remember. And the equation, the SAMT equation in terms of this modulation index will be Vc1 plus M sine of omega mt sine of omega ct. That will be the answer for that question. So if you are going only for modulation index, that is Vm by Vc. Vm by Vc will be your modulation index, right? Yes. Next, the AM wave will have what are the components of your AM wave? Yes. Okay, carrier, LSB and USB. Navjeet Chaudhary says A. The game says A. Priyanka says carrier, LAB, USB. Priyanka, LSB, that one. Okay, Soumya says A. Right. Okay, let's discuss this question also. Basically, if I write the equation of AM signal, that SAMT, which we discussed in the previous question, that is VC1 plus sine of omega mt into sine of omega ct. When we multiply this VC inside, we will go to VC sine of omega ct. Then another equation M is also there. So another equation VM, so not VM, that is VC. That is VC M sine of omega mt sine of omega ct. Now what we did, we multiply by 2 here, divide by 2 here. So that will become 2 sin A sin B formula, and that 2 sin A sin B gives us what? Omega ct plus m times Vc by 2, right? That is become cos A minus B omega c minus omega m into t, and another one is cos, that is minus here, minus cos omega c plus omega m into t. So basically this is the equation for us, right? So inside this equation there are three components what we are observing. The first component is Vc sine of omega ct. This is your carrier frequency component. Carrier frequency component. Another one is what? M Vc by 2 cos of omega c minus omega mt. Another one is minus m times Vc over 2 cos of omega c minus, not plus, omega mt. So it is having three components. The carrier frequency component. Another one is what? Another one is what? This is MVC, that is cos omega c minus omega mt. This is called lower side band, and this one is upper side band, right? So basically we are having carrier frequency component, lower side band, and upper side band. It is having three components, right? Carrier frequency, lower side band, which is having frequency omega c minus omega m, and which is having frequency omega c plus omega m, that will be upper side band. So what will be the answer for this question? So whenever you are having a AM wave, that will have a carrier frequency component, LSB and USB, the upper side bands, right? So that will be your carrier frequency, AM components which are there. Okay, next. How much is the bandwidth of your AM signal, right? How much is the bandwidth of your AM signal? Okay, the answer is CVV. What is this, Priyanka? CVV, ACVV. Okay, CCC. Soumya says C. Navjeet Chaudhary says C. Okay. Okay, let's discuss this one also. Right. Basically, what we are having, the bandwidth of AM signal. So if you draw the spectrum of AM signal, we are having a carrier frequency component here, that is at FC. We are having upper side band, that is FC plus FM, and we are having lower side band, that is FC minus FM. The gap between this lower side band and upper side band will tell you the bandwidth. So that will be twice FM. So whenever you go for the bandwidth of AM wave, that will be 2 times the massive signal frequency. Very good. The maximum power of AM wave under distortionless condition. Whenever your AM wave is having under distortionless condition, then what will be your maximum power of that AM wave? Just check it and let me know. Maximum power of AM wave under distortionless conditions. See, always remember whenever you go for these type of exams like CIL exams, right? They are mostly theoretical based exam. If there is a numerical, that is very easy numerical it will come, but you have to be more conscious about the questions. In the questions, he always put any tricky things, right? He will put tricky things instead of asking straightforward things. He will ask you in tricky way. Like this question, he is not asking that how much is the power transmitted. He says that maximum power of an AM wave under distortionless condition. How much will be the maximum power when your AM wave is distortionless? So Navjeet Chaudhary says B. Okay, anyone else? These are the tricky questions. I'm again saying, you think that they are straightforward questions, I can solve it easily. No, these are tricky questions, right? Most of the student, like in the amplitude case, where he has the maximum carrier amplitude, in that case most of the students make the mistake. This is another questions where is the very high chances of getting mistakes, right? So try to solve it. What he says, uh, you are having the AM signal. So what will be the maximum power of that AM wave under distortionless condition? See, basically, many students are here who don't know what is the distortionless condition. So, basically, whenever you go for AM signals, there is a condition that is called distortionless condition. And what is that? See, the modulation index M of an AM signal can take mostly three values when it is M greater than 1, M equals to 1, m less than 1. There is a fourth condition, this is m is equals to 0. So this is unmodulated, right? M less than 1 is under modulation. This is called as critical modulation. And the last one, m is greater than 1, that is called as over modulation. Right, we are having the four types of modulation. Generally, m greater than 1, that is over modulation, m equals to 1, that is critical modulation, m less than 1, that is under modulation, less than 1 or greater than 0, you can say. And another case is m equals to 0, that is the case is known as unmodulated. When your modulation index is 0, it means that will be not modulating any signals, right? Yes. So in that case, what is happen whenever we go for the AM signal, if your modulation index is greater than 1, there will be distortion, right? If you go in depth, that distortion is what? If you in the time domain, if you draw the signal of that one, so what is happen? The negative envelope will overlap with the positive envelope. That is the condition for over modulation. So we didn't prefer this over modulation because it is having distortions. If you use a envelope detector to detect this signal, that is not possible due to this distortion. So we will not use the m value, right? We will not use the m value which is greater than 1. So most of the cases we will use the m value which is less than equals to 1. This is the case of under modulation, or you can say critical modulation. So in practical cases, we generally use this modulation index. And how much is the transmitted power? If I'm talking about the transmitted power of an AM signal, that will be 1 plus m square divided by 2 into carrier power. So this is the formula you already know about the power of your AM signal, right? So it means if I replace the maximum value, then we will go to the maximum transmitted power. If I replace the maximum value of this modulation index without distortion, so without distortion, how much is the maximum value of m? That is 1. So if I use that m value as 1, so without distortion, that is become 1 plus 1 by 2 into Pc. So that is 3 by 2 times the carrier power. So that will be the answer is A here. 1.5 Pc. That is your power for maximum power for an AM wave under distortionless condition. Everyone understood this thing or not? Yes, please. Clear? Okay, good. Let's move to the next question. Now the question is changed. This time he is talking about the peak amplitude of DSB SC wave is given by. You are having a DSB SC wave, right? How much is the peak amplitude of that one? Just if I'm having a DSB SC wave, how much is the peak amplitude of that DSB SC wave? That is okay. Soumya says B. Okay, anyone else? Okay, let's discuss this one. So basically, we are having peak amplitude of a DSB-SC wave. So if you are going for the equation of DSB-SC, DSB-SC equation, that is what? That is M times Vm, not VMVC. Because if you remove the carrier from your AM equation, that is M times Vc, right? Sine of omega mt into sine of omega ct. So basically, this is your DSBSC equation. If I remove that carrier frequency component, which is extra in that AM wave, if I remove that carrier frequency component, the remaining part, the remaining values which will be having, that is known as DSBSC. So this is the equation of your DSB-SC signal. So now in this DSB-SC signal, if I am going for peak amplitude, again the same thing. We have to calculate the peak amplitude of your carrier signal, right? And on one more thing, because he write the answers very, you can say cleverly, because we know that this M is getting how much? Vm by Vc. So if you replace the M value, then we will go Vm Vm time, because Vc to Vc cancel out, Vm times sine of omega mt, right? This factor will be the amplitude of sine of omega ct. This factor is the amplitude, or you can say peak amplitude of your carrier. So what will be the answer for this question? That is Vm sine omega t is the peak amplitude of your carrier. Right, that is again the question is same. If he is talking about envelope, then that will be Vm. Maximum envelope value will be Vm. So answer is D here. The instantaneous voltage of DSB-SC wave. DSB-SC wave instantaneous voltage is how much? The wordings are changed, the answers will be changed. So every time before giving the answers, just read the questions carefully every time, because whenever the single words are changed, the answer will be changed for the complete questions. Like he says, the instantaneous voltage of a DSB-SC wave is how much? He is asking about instantaneous voltage. He is asking about instantaneous voltage. Yes. Every time be careful with your answers. Anurag says D. Navjeet says D. Okay, anyone else? Anyone else? No, it will be occasionally, not every day, Priyanka. It will be occasionally. If you want that every day, we are having the everyday classes that is already going on your PDA panel, right? Not here in YouTube. We are already providing the live classes every day, right? Practice sessions like this, right? Because you are having very less times, around 1.5 months. So if you want to prepare that one, that is the very good sessions for you, like we are doing today's, right? The same sessions we are that will be happen every day on your PDA panel, not here on YouTube. So he says that instantaneous voltage of a DSB-SC wave is, how much is the instantaneous voltage of your DSB-SC wave? So whenever you go for instantaneous voltage means what? Let us take, I'm writing this DSB-SC equation, that is M time Vc sine of omega mt sine of omega ct. So basically this is called as instantaneous voltage, which is available for that DSB-SC signal. So it means the answer is D here. So this M time Vc sine of omega mt sine of omega ct will be your instantaneous voltage for your DSB-SC signal. This will be your instantaneous voltage, right? That is voltage at every instant of time, that will be defined by this instantaneous voltage. DSB-SC wave will have what? The carrier LSB, USB, LSB, USB, LSB or USB, one-sided and one vestige of other. So what will be the answer for this question? Okay. Navjeet Chaudhary says B. Priyanka says B. Okay. Yes. So whenever we are talking about this DSB-SC, we remove the carrier frequency component. We remove the carrier frequency component. We are having only two things, that LSB and USB. Remember, here is OR. OR means what? That it is having only LSB or USB, only one thing. But he says that DSB-SC having both. That means and there. Right? So answer will be B here. That will have lower sideband and upper sideband. How much is the bandwidth of DSB-SC wave? How much is the bandwidth of DSB SC wave. So if you are going for DSB SC waves, yes, yes, good. If you are going for DSB SC waves, very good. DSB-SC wave bandwidth, if you are drawing the spectrum of that one, that is having only two things, the upper sideband and the lower sideband. I'm drawing only the positive side of that spectrum. That is FC plus FM and that is FC minus FM. So again, if you are going for the bandwidth, it is not having any carrier frequency component. So carrier frequency is 0, so that will be twice of FM here, twice of FM here. So answer will be C here. So the bandwidth of DSB-SC wave is twice of FM. The maximum power of DSB-SC wave under distortionless condition. Under distortionless condition, what will be the maximum power of DSB-SC wave? Anurag says B. Okay, anyone else? Navjeet said C. Twice of PC by 3. Anyone else? Okay. So if you are going for the DSB power, see, we remove the side bands. So what is the complete power of your AM signal? First, I am writing the power of AM signal. That is PC 1 plus M square divided by 2. So inside this one, we are having carrier frequency component, and this is your sideband, right? This is your sideband, this is your carrier frequency component. So what we did in DSBSC, we remove this carrier frequency component. So we are having DSBSC, we are having only the sideband whose power is M square by 2 into PC. Again, he is talking about distortionless case, so your modulation index should be 1. It means the power of DSB-SC signal will be 1 by 2 times the carrier power. 1 by 2 times the carrier power. So answer will be B here. Right, Navjeet? The answer for this question is B. Right, that is PC divided by 2. Yes, let's do the next question. Yeah, this is the questions for you. Again, the question is very good. Yes, what will be the answer for this question? He says that you are having VSB is the instantaneous voltage of one sideband, then the instantaneous voltage of SSB can be related with the DSB. How it will be related with DSB? Yes, A. Priyanka says A, Navjeet says A. So basically, whenever we write, this is the SSB, this is the voltage of sideband, right? And he says one of the sideband, you can say. That is the voltage of one of the sideband. So if I'm writing the equation of DSB, so that DSB will have what? DSB-SC will have two things. That is having upper sideband plus voltage at lower sideband. The voltage of both upper sideband and lower sideband will be same. In SSB, generally what we are doing, we are transmitting in SSB, what we are doing, we are transmitting either this upper sideband or this lower sideband. So it means we are transmitting the voltage either this upper sideband voltage or lower sideband voltage. So because we are transmitting only one sideband, it means that sideband of SSB equation, you can say, that is going to be voltage of DSB-SC minus voltage of one sideband. If you are subtract the one sideband voltage from the total DSB voltage, then that will be converted into your SSB signal. So what will be the answer? Answer will be A here. So these are the tricky questions. I'm again saying, whenever you go for the exam, just read the questions carefully. That will be not like easy, right? You have to be more conscious about the questions what he is asking and how we have to solve that one. Now he says that instantaneous voltage of your SSB upper sideband wave. How much is the voltage of SSB upper sideband wave? Yes, check it and let me know. Yes, what will be the equation of instantaneous voltage of SSB upper sideband, right? So basically, if you go for the equation of SSB, the AM equation which we drive in the starting, in that one we are having a carrier component there. Then we will have the lower sideband, that is M times Vc by 2 cos of omega C minus omega M into T. and another thing is minus m times Vc by 2, that is cos of omega c plus omega m into t. And here is the carrier frequency component is also there. I'm writing the complete equation of your am, right? That is what? That is m times Vc, not m times, that is Vc cos, not cosine of omega ct, right? That is your carrier frequency component. This is your lower sideband and this is our upper sideband if we go with that one. So which one of the following is the equation, instantaneous voltage equation of your SSB upper sideband? So if I'm going for SSB upper sideband, the A will be the answer. That is upper sideband is only this part, that is minus mvc by 2 cos of omega c plus omega m by 2. So answer for this question is A. Answer for this question is A. Clear? So every time you have to write the complete equation, then you will get a better idea, like we did in the first questions, right? Here is the complete solution for that one, how we got that equation. Now he is asking about the next question, that instantaneous voltage of SSB lower sideband. SSB lower sideband instantaneous voltage is how much? So if you are going for instantaneous voltage of lower sideband, right? The lower sideband equation, what we calculated in previous case, that is mvc by 2 cos of omega c minus omega m into t. So the what will be the answer? Answer will be A for this question also, right? Okay, next. The SSB wave will have, so which are the component of your SSB wave? What will be the answer for this question? So basically, yes, very good. C. Priyanka says C. Harry says C. Yes. Okay, very good. So basically, this answer is C. The SSB wave either have lower sideband or having the upper sideband. Yes, answer is C for this question. The expression for total power of your SSB wave. The total power of your SSB wave, what is the expression for that one? Yes? Answer. Navjeet says B. Okay, anyone else? The expression of total power in SSB. The B. Okay, so basically, whenever you go for the expression for power, the power expression for AM signal is what? First, write that one. 1 plus m square by 2 times PC, right? So that will be PC plus m square by 2 into PC. So this is your total sideband power. This is called sideband power, right? Sideband power. So in this sideband we are having two things. Upper sideband is also included in this one, and lower sideband is also included in this one, right? So we are having two types of sideband, upper sideband that is also included this one, and lower sideband. So it means if I calculate the power of upper sideband, that will be half, because same amount of power will carry by lower sideband and same amount of power will be carried by your upper sideband, that is also m square by 4 into pc. And if you add them together, then you will get the sideband power. So it means in that case, what will be your expression of total power? That is pc m square by 4. So B will be the correct answer for this question whenever you are getting for the total power. Now the maximum power of SSB wave under distortionless condition. It's easy now. Tell me the answer, because we discussed about this one previously in detail. The maximum power of SSB wave under distortionless condition. Yes, very good. That will be because in the previous case we calculated the power, right? Power of SSB, that is m square by 4 times PC, and this time the m value for distortionless modulation condition, m is getting 1. So the answer is PC by 4. Very good, Navtej and Priyanka. Yes, that's correct. Yes, now we are talking about the frequency modulation. Yes, read this question and try to give the answer for the frequency modulation. He says the FM modulation process in which the change in the frequency of carrier signal and its rate of change are made proportional to the instantaneous variation in what? Message amplitude only. Okay. Navjeet says B, message frequency only. Okay, I got two answers. A answer from Priyanka, and that is B answer from Navtej. Anyone else? Yes. So basically what is happening, if you are writing the equation of your FM signal, what will be the equation of SFMT? That is AC or VC sine of omega CT plus KF integration of m tau d tau. Do you remember that one or not? Instead of using, I'm taking that tone modulation case, it means your m of tau is getting, let's take cosine or sine, it will be up to you. I'm taking sine of omega mt. If I replace that, Vm is also there. If I replace that equation in this Fm equation, so we will go to Vc sine of omega Ct plus Kf. This is Kf, frequency sensitivity. And when you integrate sine of omega mt, when you integrate this one, so what we are getting? Vc sine of omega Ct plus Kf into Vm divided by omega m, and sine will be converted into minus cos. So what are the factors on which your frequency will depend? It will depend on both amplitude as well as the frequency. So it will depend on both things. Mass is amplitude and its frequency. Remember that thing. It is not only depending on the amplitude. The frequency deviation in FM refers to the extent by which the carrier frequency is varied from its unmodulated value, that is proportional to what. So whenever we go for the frequency deviation, let us take you are having a center frequency fc, right, and your masses means carrier frequency will deviate from that one. This is called as instantaneous frequency. So from here to here, right, this is called as twice of delta f, and this from the deviation from the center frequency is called as delta, the frequency deviation. That frequency deviation is proportional to the what? It is proportional to the amplitude of that masses or no? Tell me the what will be the answer for this question. Yes. So here we are showing that graph that your carrier frequency or carrier frequency, this is the carrier frequency, not like this. Here we are having the time, and on this side the carrier frequency is like this, right? The center. So if you are taking the t axis here on this one, so how the carrier frequency or instantaneous frequency of your carrier will vary according to your massive signal, this graph shows you that thing. So in that case, what he is asking that this maximum frequency deviation, right, or frequency deviation you can say, will depend on which thing. He is talking about proportional. So if you are going for frequency deviation, that is delta, and its value is kf into vm, kf into vm, so it will be proportional to your masses amplitude only, right? Masses amplitude, as you see here, the amplitude will change, the frequency deviation is also changing. So the answer for this question is a very good. The rate at which the frequency deviation take place depends on which factor? The rate at which, read the question every time he asks the different question. He says that rate at which the frequency deviation take place depends on which factor? The rate at which frequency deviation take place will depend on the factor, that is your massive signal frequency. That will depend on your massive signal frequency, right? So the answer will be B here, right? Massive signal frequency. He is talking about rate, not normal value. The level of frequency deviation depends on that. What value? He is talking about the level of frequency deviation, right? Level of frequency deviation will depend on which thing? Whenever he is talking about level of frequency deviation, what is the meaning of that one? That how much the carrier frequency shifted from its original value, that is called as level of frequency deviation. So if your center frequency is fc, then how much is the carrier frequency shifted from that center frequency? That is known as your frequency sorry, that is known your level of frequency deviation. So it means that level of frequency deviation, how it will be, how much it will be deviated from its center frequency. Yes, correct. So that will be delta is equals to kf into vm, right? That will be depending on the massive signal amplitude. So every time the question is different, you have to read and understand what he want to know in that question. The proportionality constant kf in fm expression having the unit. So what will be the unit of your kf? Tell me. Yes, it's easy question. D, no unit. Okay, anyone else? See, basically what we are seeing here, the delta is frequency deviation is equals to what? Kf into Am. So if I write the Kf value, that will be delta by Am or not? So Am or Vm, what you want to take, Vm. So basically this delta is frequency deviation, so its unit is in kilohertz or hertz. This is the voltage, its unit is in volt. So whenever you go for this kf constant, right, this kf frequency constant, that will be unit having unit kilohertz per volt. So the answer is A here, right, Priyanka? It's not D. That is not a unitless constant. It is having a value whose unit is kilohertz. Generally, we will have the unit of kilohertz per volt. Right? Okay. The modulation index MF of a FM signal is defined as, whenever we talk about the modulation index, how much it will be defined? So whenever you go for the modulation index, we write one equation, that FM equation as FMT. That equation is what? VC sine of omega CT plus KF VM by omega M, right? Omega M multiply by sine integration become cos minus cos omega mt, right? That equation we write. So this factor, this multiplication factor generally represent the beta. If you are taking the kf into radian per second, then omega m will also be radian per second. If kf is going to be 2 pi and I'm taking that kf in kilohertz, then that omega m is also be 2 pi into fm. So 2 pi to 2 pi cancel out. So that beta or mf. Okay, beta generally we represent or mf, right? So MF, the modulation index of FM signal is getting KF VM by FM, right? So basically this time its unit is kilohertz per volt. And in this case, if I'm directly take here, it is radian per volt. Remember that. That is the difference. So here MF is getting how much? KF AM, KF VM by FM. So MF is getting KF VM. We are generally talking about the delta, the frequency deviation upon FM. So that is the formula for modulation index, and that will be B. Yes, good. So this is the last questions, right? Tell me that one. Which one of the following is the instantaneous voltage represents the FM signal? Which one of the following is the instantaneous voltage of your FM signal? Navjeet, also correct. Yes. Yog is also correct. Yeah. So basically, whenever you go for the equation of FM signal, that equation is this one. That is VFM is equals to VC sine of omega CT plus MF cos of omega MT. Right. So these are the questions from your analog communications, right? So I will bring one more session or two sessions. Then in that one we will bring some questions from different subjects. I will bring that one. So if you want to if you want to prepare for that CIL exams, so every day we are having such live sessions in which we solve these like these type of questions in that one. That is really helpful for your CIL preparation. So you can join YourPedia for that purpose. If you are still having any doubt, you can ask, right? So these are the questions which we have to discuss today. So answer for this question is A. Yes. Please, if you are having any doubt, you may ask. Any one of you want to know anything, then please ask. I'm again repeating the thing. Okay, then let's conclude this session here. So we will have the next session with another topic. So let's meet in that session, right? Okay, everyone. Yes, okay. Priyanka, if I'm talking about the level is easy, you can say. That will be easy, not even moderate. It will be easy. Like this type of question, but some questions are tricky. You have to be, see, whenever you go for these exams, CIL, BEL, like these exams, in these exams, the level is not that much difficult. The level is easy, but sometimes he will ask the question in different way where you can make the mistakes like I did today. I bring some questions which are tricky one, so you have to be more focused whenever you give the answers, and the questions are easy, right, Priyanka? Yes. Okay, then let's meet in next session. Okay, then bye.